Hello, welcome, good morning. I'm here broadcasting live from the School for Poetic Computation. There is actually a class going on in this space, but I think the sound is okay, but I will be checking periodically a chat that I have hooked up there if someone's going to tell me that I'm being too loud. But hopefully everything's going to be fine. If you're watching this in the archives, I encourage you to look at this video's description and you can find some time codes where things will happen, because right now I'm just going to do some setup and introductions and that sort of thing. The first thing I have that I'm very excited about today is that I've worked out a slightly better sound situation. So I'm going to test it by saying,
Hello.
And welcome to
Cutting Rainbow.
Did that work? So let me know if you heard those in the chat. I can see that I'm broadcasting live. Let me know if you heard those sound effects and if the volume was okay, because I was able to, in Wirecast, configure two different audio inputs. So there's an audio input coming from my mic, and there's an audio input coming from this laptop. I'm going to say where these sounds came from and give credit to them in a second, but there's an audio input coming from my mic and audio input coming from this laptop, and I can actually adjust the volume of them separately. So I would like to know in the chat, how's my voice volume? Is it clipping? Is it too loud? Is it too soft? How's the sound effects volume? Okay, and just in case you're not really sure, let's play a little music. Got to get started this morning with a little dancing. How's the volume? Is the music too loud? Too soft? Because I can change it. I can make it lower. I can make it higher. Anything your heart desires, I could do with the sound. I can also dance more. It might be slightly too loud. Okay, I'm going to go in here and I'm going to do edit shot. I'm going to go to whiteboard Canon audio and I'm going to turn it down about 25%. Okay, and that is at, let me just see, the number it's actually at is negative 7.67. So I also need to change it in one other place. You have to bear with me. I know you're seeing the wrong screen for a second. I'm back here, and I'm going to change. I'm going to edit shot, and I have to go to. This is confusing. Okay. I know what to do. Go to here and do this negative 7.67. So the audio should be exactly the same now. Okay. A voice is good, music too loud. Okay, I'm going to play the music again. I turned it down a little bit, about 25%, and you let me know how it is. Now I'm talking and playing music at the same time. Now, typically I won't be doing that, but okay. How is the volume now? A little bit too loud still. Okay, I'm going to turn it down. It's kind of crazy. Okay. How many times are we going to do this? Once I get it right, I won't have to do it anymore. Okay, here, volume. Now I'm turning it down to negative. I'm turning it way down. Let's see how this goes. Close, click away, click back in. Okay, here it comes again, everybody. It might not have changed the volume, actually. It might not be crazy, because if I, yeah, it doesn't seem, does that seem quieter now? Sometimes I have to click in and out, but usually that will do the trick. Let me make sure I did the right thing. Yeah, it's at 10, negative 10. Okay, let me know, how is that better? Yes, I am. It is sort of machine learning dancing. It doesn't seem to have changed. It's crazy. Frustrating. Okay, hold on. I wonder if I had this issue before, and hold on. No, that's not the. Hold on. I'm going to look into this. Let's see. Hold on. I'm going to turn it way down. So it's basically, I'm turning it all the way down, so like there's really kind of no way you could even hear it. And this is up, and this is way down. And now, yeah, okay. Oh. Okay, it definitely went down, right? It's very quiet now, right? I don't know if you can even hear it. Whoops. Play the sound twice. Okay, so that's working. I turned it like way too far down, I bet. Okay, so let me turn it a little bit. I think maybe it's just my small changes weren't doing very much. So let me turn it to here and see how this goes. It's too quiet now, yeah. So this is probably good, right? There's a little music, but not too much. Yes, good? This is great. This is, by the way, I don't know if anyone in the world is going to be watching this again. This is like, I can't believe this is going to be the first 20 minutes of this live stream. Is me trying to set the volume level. Okay, now what about these sound effects?
Cutting rainbow. Cutting rainbow. Hello.
Okay, how are the sound effects? Volume level seem like you could hear them, and if I was doing a p5.js sketch with those sound effects coming, it would be okay? Let me know in the chat. Yeah. Yes, Oliver, go forth and GIF. I had a lot of people enjoyed those, so you're welcome to do it again if you like. Okay, they seem good. Okay, I'm going to leave it at this for now, and I'm just going to do one other thing here to set the volume on the other camera. And I can adjust it. Oh, the camera went off. I swear I changed the, that's very frustrating to me. So I also supposedly fixed some settings on my cameras so they don't go off after 30 minutes, but that didn't seem to have worked because that camera just went off. Okay, so welcome and good morning. This is
Cutting rainbow.
with me. And I have some new sound effects to work with today, as I'm going to do some more stuff about sound in JavaScript using the p5.js sound library. I want to just quickly thank, this is, I guess I can open this up here. So this is a free and Creative Commons sound effects package. I didn't fix the camera problem, unfortunately. I'll have to look into that later. I'm using something called Magic Lantern, which is a camera firmware for these Canon 5D cameras, and it has some settings to stop the Canon from auto-powering off after 30 minutes. I thought I got it right, but clearly I did not. So I'll have to look into that later. But anyway, so this is a free sound effects package. It is by Arnaud Farr on GitHub, who is the co-founder of, I'm just going to, whoops, co-founder of Studio Nora. I encourage you to check out the Studio Nora website and say thank you to Arnaud Farr, I don't know if I'm pronouncing that correctly, for creating this free sound effects package. Because what I want to do today, amongst many things, is look at how to play sound effects in a p5.js sketch. But okay, so this is Coding Rainbow. It is a weekly show. I don't know if that's the right word. I mean, if it involves dancing, then maybe it's a show about creative coding and other types of coding things and fun times and education and being welcoming to anybody and everyone all over the world and perhaps in the universe when the aliens come to learn about JavaScript. I welcome them as well. And so I'm doing this about once per week all the way through the summer, and I hope to continue it in the fall, and I have some new ideas about some new things I'll try in the fall. But right now I'm basically doing two things. Well, I'm doing more than two things, but I'm recording these live broadcasts. Parts of the live broadcasts get edited into standalone video tutorials. I kind of have video tutorial sequences, like my tutorials about sound will probably be, when all is said and done, about 10 videos, and then I'm doing these sort of standalone coding challenges. So today it's about 10:45 a.m. Eastern Time, New York City. I'm going to be here for at least a couple hours. I've been here already. Oh, I didn't hit, this has only been 11 minutes so far. It feels like it's been way longer. I'm going to hit record, I'm now recording to disk as well, so I have a disk backup of this live stream. And I'm going to be here, I would say, until at least noon or 1, something like that, doing tutorials and examples. So now, let me say a few words. If you would like to, a couple things. If you would like to subscribe to an email list where I send out emails when I do a live broadcast, you can do that at the new Coding Rainbow, at the new
Coding Rainbow
website here. So this is, if you go to codingrainbow.com, right over here, you can find this website. If you scroll down, there is a place here to put in your email if you want to get email announcements when I'm doing the live streams. Typically, they've been around this time, 10 a.m., 11 a.m. Eastern, Monday or Tuesday, and sometimes on Fridays. I'm committed to doing at least 4 per month, but sometimes I get to more of them. And you can also, the things that I would also encourage you to do if you're interested is subscribing on YouTube, which you'll also get notifications, as well as if you're interested, you can subscribe to the Patreon, which for a monthly fee, you can participate in this Slack channel that I've got going where we talk about other sort of things related to the channel and suggest topics and answer questions and that sort of thing. Okay, so, oh good, I'm glad that you like the excessive use of sound effects. I actually am hoping, I would like to, this is my thing, I want to have like a sound board where I just have like certain sound effects tied to buttons and I can just press them at any time. Right now I have to go over here and say, it is
Coding Rainbow
with me, and I hope that you will enjoy some humor during this. I don't know. Okay. So that's that. So what do I want to do today? So first thing I want to do is last Friday I did some, first I'm going to check actually I just want to check to make sure I got it, if there's any messages about the sound being an issue, of me being too loud. So I'm coming over here. I don't see anyone messaging me saying I'm being too loud, so I think it's okay. So the first thing I want to do is I want to make some corrections. I have something to admit to you guys, which is that I really don't know what I'm doing. And I did a coding challenge on Friday about the Mandelbrot set. So I'm going to pull it up. And there was, some math errors and some weirdness in it that I would like to fix and clarify. So I just want to do that. And then what I think I'll start with today is a coding challenge transitioning from the Mandelbrot set to the Julia set, which I think is exciting and interesting. So that is what I would like to start today. And if you have questions or comments, you can ask them in the chat. I've got an eye on the chat right over here, and I've got an eye on my laptop over here. One thing I really want to get is a bigger screen where I can see what's on my laptop up there, because I feel like I'm doing this a lot. So number one is I don't like you looking at the top of my head. It's slightly balding over here. But also it's just when I watch back some of the videos, it feels weird that I'm looking down. I like to look up and look at you and feel that I am present and here with you as you are with me. In
Coding Rainbow.
the volume is okay? Okay, I'm looking at the chat, no one's saying anything. All right, so let's get set up here a little bit. So the first thing I want to do is open the Atom editor. The other thing I want to do is benchmark the pixel operations in JavaScript versus processing. Because as I was playing around with the Julia set last night and getting ready for today, I ran some pixel stuff in processing and it was super fast. So I'm tempted to think about using that today. But so this is the Mandelbrot set code, which is what I'm going to start with. I need to run a little local server to run it in the browser. And other thing I want to do is clean up the code a little bit. What I might do is maybe I should do an actual part 2 of the Mandelbrot set, like part 2 corrections, because I feel a little guilty that there are like kind of major flaws in my previous example, although it works. So let me go now. I can close these windows here. And I can go to localhost. I don't need the Coding Rainbow website anymore. I'm going to go to, Dragon Hunt 3 asks, why do you need a local server for JavaScript? So you don't necessarily need a local server. So for example, let's just see. I'm going to go to this thing that I want to open up, which is the Mandelbrot set, the thing that I did last week. And I'm just going to like double click on index.html, and there you go. Whoops. And you can see that it's working fine in this goofiness zooming thing that I implemented. And you can see that it's actually opening the project via the file path. So I just opened that HTML file directly in the browser, and this worked just fine. And I would say probably, I'm making this up, but 90% of the things you might do will work that way. But there are certain operations that are forbidden through the local file system, or I don't know if forbidden is the right word, but just won't work properly. And I find that it's safest, because ultimately when you deploy the thing you made in JavaScript, it's going to be on a web server. So if you want to mirror that behavior precisely on your laptop to know things are going to work the way they'll work when you deploy it, it's good to run a local server. So I just have a habit of doing that. I think it's a good thing to do, but you should live dangerously and just open stuff up however you like. Okay, so I'm going to go here. And we can see here, Mandelbrot set. I'm going to open up the JavaScript console. I'm going to, oops, that's fine. I'm going to make this a little bit bigger. OK, great. OK, so here we have the Mandelbrot set from last time. What was I doing? Oh, I wanted to sort of see how fast this was rendering. There's a couple things I want to do. Let's see how fast this is rendering. And a way to do that, let me add, I'm going to add, I'm going to make something called frame rate div. Ooh. Okay. I'm getting some messages on. I gotta turn over my phone. I gotta turn this on mute. Okay, hold on. Sorry. OK, so frame rate div equals create div. I'm just adding a little div on screen so that we can take a look and say, I'm going to say frame rate div.html. I believe just the frame rate function in p5 will give us the frame rate. Let's see if that worked. Yeah. So you can see this is actually only rendering at about 13 frames per second. And this is what, a 200 by 200 canvas. That's quite slow. Let me go open up processing. I'm tempted. I like doing these in JavaScript because it's in the browser and I can attach sliders really easily. But let me open up processing. And what I'm going to do is I'm going to open up my Mandelbrot set example. And actually, there's mistakes in this example as well. And I'm going to make this, I'm going to save this as Mandelbrot a P for processing. And I'm going to add a setup and draw here. And this is 640 by 360 pixel wise, and I can just say print line frame rate and run this. Yeah, you can see that processing is processing the pixels at 60 frames per second at a higher resolution. So let me go to 200 by 200. And you can see easily, this is the resolution I was doing in the browser, and we've easily got 60 frames per second, and in the browser, we've got 13 frames per second. Now let me check a couple things. Let me check a couple things because, and this is because one thing that's a really key value here is the max iterations. So where do I have that set? At 100 here, and in the browser code, I have that set as 100. So I guess my question now is, performance-wise, doing these pixel operations is rather slow in the browser. And I kind of enjoy it. I wonder if this morning what I might do is switch over to use processing, go over the kind of mistakes that I made in the Mandelbrot set, and then do the Julia set in processing with some interesting animations. It'll be much easier to animate more quickly in processing. Yeah, so I know that using WebGL and a shader would increase the speed of this. I'm not prepared to do that today. I would like these tutorials to be kind of simplistic and friendly, beginner friendly, and really just be about the algorithm. Also, I'm sort of waiting. I would like to, if I'm going to do this at some point with WebGL, I would like to sort of stay in the p5.js world. And I think that I would need some WebGL tutorials to kind of lead up to that. I'm making lots of excuses because mostly the answer is, I don't know how to do that all right now. Or web workers. Everyone has great suggestions. But this channel, Coding Rainbow thing, is really not typically about sort of deep diving into elaborate ways of doing things for optimization or performance. It's really about the basics and algorithms and how to get up and running quickly. So I leave that to you, the internet audience, to kind of build off of these examples and make optimized better, better is the wrong word, but optimized, more streamlined, high performance versions of them in different contexts and share those, and then I'll come back and share those as well. Yeah, and Casper in the chat makes a good point, which is, why am I redrawing the set for every frame instead of only redrawing when the slider changes? And yes, that would absolutely be way more efficient, and I should. That's absolutely something that I should be doing. Okay. All right. So I think what I'm going to do is let me stick first. I'm trying to decide. I think I'm going to leave my Mandelbrot tutorial as is and just go over here in the live show, kind of the things where I went wrong and improve the example, and then I will do the Julia set. So looking at the code, actually, there's really only one spot where I have kind of a major issue, and it's here. So I was kind of arbitrarily, there's a couple things. So the whole point of, not the whole point, but if you remember, if you were watching last Friday or watched my Mandelbrot tutorial online, the idea behind the Mandelbrot set is to test what happens when you take a certain complex number and apply an iterative function with that complex number essentially as the seed over and over again. And with certain complex numbers, what happens when you iterate over and over again is that value will be bounded, meaning it will stay within a finite range. With other complex numbers, it will tend towards infinity. The Mandelbrot set is the set of complex numbers for which that iterative function remains bounded. So how do you test if something remains bounded or goes to infinity? Well, you have a complex number. Oh, I didn't turn this light on over here. Let me turn this light on. You have a complex number like a plus bi. So the question is this number tending towards infinity or remaining bounded? So my quick and dirty way in the code was to just say, take the a and b components of the complex number, add them together, and take the absolute value. So this is not completely unreasonable. It's pretty incorrect, but it's not totally unreasonable because, as the complex number gets bigger, the a and b values will be bigger. And whether they're bigger negative or bigger positive doesn't really matter. Add them together. If it's a really big number, it's probably going towards infinity. But this is majorly incorrect. Because at the very least, I should be doing this, right? If the thing is getting bigger, it's really about how far away from 0 are the A and B components getting. So I shouldn't be, right? If this is like negative 1 gazillion and this is positive 1 gazillion, A plus B will be 0 and the absolute value of that will be 0, which isn't correct because having A as negative gazillion and B as positive gazillion, that's a really big complex number far, far away from 0. So on the one hand, this is really what I should be doing if I want to use this idea of just sort of testing how big those numbers have become. However, a sort of proper way of doing this would really be to say, what's the distance, what's the Euclidean distance of the A and B components from 0, 0? And to do that, the formula would be the square root of A squared plus B squared. Because you can essentially think of A as kind of like an X value, and B as essentially like a Y value. So you have an X and Y. And then what is the distance from 0, 0? It's, this is a right triangle. So this distance, X squared plus Y squared equals that distance squared, or that distance equals the square root of X squared plus Y squared. So really in my code, if I come back over here, if I'm checking the chat, no one's correcting. If over here, what I really should be doing is saying the square root of A times A plus B times B. And then there's also this question of, what do I need to test if it's greater than? And to be honest, this is really an open question. In the Julia set, there's actually a specific way that I've seen in implementations to calculate a certain escape value for different seeds, complex number seeds, and we'll see that when I get to that. In the Mandelbrot set here, I would say, I've seen commonly, and I don't recall now if there's a specific reason for this, but commonly just checking if it's greater than 2 will work. I know what I'm thinking. I know why I'm thinking of this. So let me look at this for you guys. So let's look at the results here. Now, so if I refresh this, you can see that checking 2 is just fine. And actually, I want to go back and not color it in. So I want to just change this to 255 for a second. Whoops. So again, the Mandelbrot set is just the set of numbers where it remains bounded. Everything outside of these black pixels, it does not remain bounded. But when you see a visualization of the Mandelbrot set, what you're actually seeing is, well, it looks all pretty and there's different colors and different alphas. Yes, exactly. So hello. There's somebody at the door. Yes? Can I help you?
Yes, you may. What is poetic computation?
Unfortunately, I'm not available. I'm doing a live broadcast right now, so I'm not available to answer that. There's a class going on here, and there's a school. Yeah. So I would go to the website, SFPC.
School I understood.
Yeah.
Poetic computation.
I only have a long, complex answer to that question, but
Is it poetic or mathematics?
yeah, it's an open question, I think. Okay, I guess I could have brought him in to have a conversation about that, but I decided to turn him away and not get too distracted. Anybody can walk in here, I guess. The door is open. By the way, I'm just curious, could you hear the other person's voice? Or no, I wonder if my mic picks it up. Let him enter. That was an exciting moment. Okay, so let me come back here. I should have let that go. Spontaneity is much better than me rambling about the Mandelbrot set. It's too late now. I sent him away. I was afraid. I panicked. I saw Oliver's comment about the square root. Okay, inaudible. Okay, so that wouldn't have worked anyway to have this conversation. Okay, so back to what I was saying. So usually you'll see a lot of colors and things in the visualization. So why do you see that? Well, here, let's look at the code again. The code, right, is checking to see if at any point within 100 iterations, if the distance becomes greater than 2. So in that case, I lost my train of thought because I'm thinking about the square root question of the performance thing. I'm going to get to that. Hold on. Plus a person came in. I need a sound effect. Is there like a calming? I think there's like a calming one. Maybe the music is calming. Okay. Or perhaps like a whoosh. It's like a wave. Okay, unnecessary sound effects. Okay, back to what I was talking about. So I really have lost my train of thought here. Okay, so there's a certain number of iterations. It might take 5 iterations, 10 iterations, it might take 99 iterations, but at some point the distance goes beyond 2 and it's not a part of the Mandelbrot set. If we choose to color each pixel according to how many iterations, we're going to start to see a variety of colors. And so that's what's happening here. I'm doing a mapping of the number of iterations between 0 and 1 and taking the square root of it, and then mapping that to some brightness value. And so if I add that back in and refresh, you're going to see that, let's think about it. So the brighter it is, the more iterations it took before it became unbounded. So you can see, I think that's right. Somebody correct me in the chat if I was wrong. You can see that it starts to get brighter and brighter as it gets closer to the actual Mandelbrot set values. But you'll notice here, this circle kind of ends here. That's because I'm allowing it to become unbounded after 2. So if I were to change this to something like 4 and hit refresh, you can see that I've got a sort of further set of gradations further along. And if I change this to 16, you can see that there's sort of a slight refinement there. And then also I could say like, oh, well, why don't we see if it goes up to 1,000 iterations. And then, oh, that kind of did something crazy weird. So, because then the mapping, there's not a lot of room for, I need to do a better job of the mapping because, that range is much too big to map into those colors, and the things go to infinity rather quickly. So, so it looks like 100 is actually a reasonable number, and I might just put this at 4 to have it sort of seem like I'm getting a nice set of a range of colors. Okay, so I wanted to just sort of bring that up. I don't know. There's some chat going on here, but there's too much chat, so I can't see. So now, Oliver in the chat brings up a really good point. We had this whole discussion about performance. So you have to realize that this is a nested loop for every pixel. And for every pixel, I'm doing this like mathematical operation possibly like 100 times. So there's a lot of mathematical operations. And one of the slowest things you can do on a computer is square root. So in that sense, if we look at this now, you can see it's running at about 12 or 13 frames per second. In theory, it's possible that if I go back to my original absolute value of A plus absolute value of B is greater than 4, we might squeeze in some higher performance. And you can see, yeah, I'm kind of consistently getting more up to maybe 14 frames per second. It's quite similar. Oh, and you can see here the difference, right? The difference between where it's finding those bounds. You get this kind of like kooky little, I don't know what to call those, like arcs. So the Mandelbrot set is really probably the same, although it's questionable, to what degree of accuracy. But you can see that the pattern has changed slightly. So I wanted to mention that, and I think for kind of purity's sake, I'm going to leave it as this, and let the sort of optimization discussion happen from there. Okay, so that was the first thing I wanted to make sure I did today, and I think that mostly that kind of wraps up my discussion on the Mandelbrot set. So what I want to do now is transition to looking at the Julia set. I think that I will do this in processing because I want to show you kind of an interesting animation with it, and that I can get a much higher resolution and faster speed animation in processing. And I'll obviously convert the code back and forth. The downside, of course, is that I could use nice sliders to change the Julia set constant, but I have another idea for how to do this. So, oh, right. So Dragon Hunt 3, yes. Okay, so people in the chat are making an excellent suggestion, which is that I don't need, right, this is so smart. I know this, and I've done this in many other scenarios, but for whatever reason, it just didn't occur to me right now. So here's a really good suggestion. Look at this. If the square root of this operation is greater than 4, is 100% identical to saying if, forget about the square root, if this value is greater than 16. Let me go over here to the whiteboard to explain that if that's not clear to people. So if I say a squared plus b squared, the square root of that, if I'm trying to test if it's greater than 4, I need a paper towel here to do some erasing. Right? What if I square both sides of this equation? Well, if I square that side, I'm left with a squared plus b squared. Square that, 16. So these are absolutely mathematically equivalent tests, but I have gotten rid of the square root operation. So in that sense, I've made it much faster, and you can come see that over here. 5th grade math. Yeah, Casper makes a great suggestion in the chat, which is that he says, he writes, you should hook up your code to an online service so that people coming in later can code along. And yes, this is actually something that I have been thinking about, having what I'm typing tied to a web editor, and every keystroke that I type appears in a web editor, and people could sort of like pause my typing and like play with themselves. But this is something I will get to later. Okay, so let me go to processing. And I'm going to close this right now. Here on
Cutting Rainbow.
with me. And I am going to minimize this, go over here. Now, first thing I'm going to do is save this in, I have that here already. First thing I'm going to do is I'm going to correct a few things, which is I'm going to add this in here. Let's just take a look here. And then I'm going to do the same. I want to do the same mapping. So one thing I'm going to do actually is I'm going to change color mode. Here's another thing I can do. I can change color mode to 1, meaning the colors, instead of having a range from 0 to 255, just have a range between 0 and 1, which will make sort of the math easier. And then I can actually just say here, the square root of number of n is the number of iterations divided by max iterations. And this needs to be a float. And then this needs to be a color. Whoa. I think there's like some, like maybe there's a gym upstairs. I can't remember what's upstairs, but like the ceiling just like partially, it didn't really like cave in over there, but some like dust just like fell down from the ceiling and I heard a crackling sound. So hopefully that's happening again. Hopefully the whole ceiling's not going to cave in on me. Let's run this and see if this looks right. Let me go back to making this rather high resolution. I'll make it 640 by 480. That looks about right. I want to get kind of more. Let's just check something arbitrary. Yeah, whatever. So this looks good. Great. So now I've got the Mandelbrot set, and I've got it a little bit, the nice thing about processing here is, okay. I really wish I had fixed that camera problem. The one nice thing about the camera issue is that it gives me a good sense of time. Like I know, okay, I've been doing this for about an hour, 40 minutes. I do have a clock over here, so 40 minutes. I really want to get to the sound stuff. So I'm going to do this Julia set. And then sound, more sound. Okay, so let's look at this. I'm just curious. I mean, one of the nice things about processing here, I'm just kind of curious what happens if I say full screen. Let's take a look at this in all of its glory. Look at that, see? Oh, and I've got a little camera issue there. Mathieu, who does a lot of the editing of videos after the fact, is always telling me to make sure I like I have a good like screenshot, but I need like thumbnails for the videos. So I'm making some now. You guys can snapshot them as well. Okay, I'm reading the chat. Okay, so I was curious. Oh, but you can see, so that was running, by the way, full screen was running only about 8 frames per second. So I won't really be realistically, without using a shader or some kind of fancy hardware accelerated thing. But I'm going to leave this at this. Okay. Oh, I can't have size and full screen. Okay. So here we go. This is the Mandelbrot set in processing. So I think, okay, so let's think about this. So let me pull up, I want to talk about the Julia set for a second. And you guys let me know how I'm doing. And then I'm going to record it, I'm going to live code it and do a tutorial about it. So let me come over here. And I'm going to kind of do this twice. I'm not over here. Oops, this camera's off. Okay. So first of all, I believe the Julia set is named for a French mathematician. Mandelbrot set named for Benoit Mandelbrot. The Julia set is named for Gaston Julia, I believe. We'll look that up on Wikipedia or Paul Bork's site or any number of places where there's a description of it. And the Mandelbrot set works like this. This is the complex plane of complex numbers a plus bi. And for each one of these values, we take the function f of z equals z squared plus c. So we start with c being one of those numbers. And we do this function over and over and over again. So another way I could write this is f of z, or z sub n plus 1 equals z sub n squared plus c. The Julia set works in a similar way where z sub 0 equals the given number on the complex plane that corresponds to the pixel we're about to color. But c is a constant, a specific constant that's picked. So in other words, I'm going to go through this in more detail when I write the code. Okay, I was checking the chat. People are talking about something. So the class, I think, is on a break, by the way. Can you guys hear voices, or my mic doesn't pick that up? I hear people there's a kitchen right back here. There's a kitchen. People are making coffee, having drinks. Perhaps I can play some music for them to dance. Okay, no. So let's go to the browser again. And let's look up. There was a nice page that I was looking at. Maybe Wikipedia will do just fine. Yeah, so this is so these are various patterns that you'll get with particular constants. So we can try plugging these in and seeing if we get this pattern and see if it works correctly. Ooh, 3D Mandelbrot fractal. That sounds interesting. Okay, so I'm trying to think of what else I want to say about the Julia set. Let's look at also, I use this site a lot as a resource. Gaston Julia. And you can see, this is a great, the Mandelbrot set is like an index into the Julia set, which is great. So like you get different patterns for different points that you would pick. This is great. This is a great diagram. So, and actually it would be worth showing this relationship. Okay, and then, yeah, this is a nice, so one of the things that I might like to do is actually put the two next to each other And as you mouse over the Mandelbrot set, you see the Julius set fractal next to it. Ooh, that would be a good thing to do. Okay. Okay, so I am going to, I think I'm ready for this now. It's going to be actually really easy to do. I'm just changing this to like the Julius, like what? Let me just show you. Let's just do this really quickly. Like let's pick one of these. Like let's try this one. So I really just want to pick, just basically plug these constants in there. And this is a minus. And that's doing the trick. Now, I didn't get the right one. Now, it's possible I'm just at the wrong scale. Oh, you know, there is, that's interesting. Why did I not get, oh, that's a negative number. There we go. I didn't see that was negative. Oh, good. There we go. Yep. So you can see how easy this is just to get the Julius. I just did it. So this is kind of funny that this tutorial is like kind of the shortest ever, but I think there's a bunch of interesting things I can add to this, and I should make this a variable too. So let me go back here to what this was. Whoops. Take this out here. There were some things about this. And so what I want to actually do is I'm going to make this double wide and have you be able to like mouse over the Mandelbrot set and see the Julius set. Okay. Oh right, I'm checking. So there is a thing about the Julius set in terms of checking about how it diverges. And what you want to do for that is actually check its distance from this particular constant, not from 0, 0. Let me just, in the end, it's kind of worked anyway, but really what I should be doing is creating, so I'm going to do this during the tutorial. Okay, so I just want to kind of like look at this page to see if there's any additional explanation. Typically, soon. I thought, yeah, this is actually just explaining as diverging to infinity. It's sort of assigned to be part of the set. Precise images, yeah. Oh, the well-known Mandelbrot set, okay. Connected or disconnected. Disconnected sets are often called dust. That's interesting. Relates to various domains of C. If C is real, then the Julius set is mirrored. Oh, that's interesting to see as well. So that's interesting to see. Oh, so hold on. If the Julius set is real, if the value is real, so in other words, if I were to take a real value, whoops, you can see that it's symmetrical. So that's interesting to see that we only get the A symmetry if we have an imaginary number. Okay, I'm just making up this here, but I think you could. All right, I can't look at the chat anymore. It's off you guys are having a very interesting conversation. Okay, I got to go do this Julius set example because I want to move on to sound. And let's just say, let's just use 16 as a number for right now. Okay, arbitrarily. What's 16 times 16? Just out of curiosity. Yeah, whatever. Okay. Yes, oh, and you can also do z cubed or z to the 4th power. Those are super interesting as well. I'm going to leave that for another time. Okay, let me just make sure there's no important messages anywhere else. I am broadcasting in Twitch. I think I'm going to stop broadcasting to Twitch. I'm not really building an audience there. YouTube here, we've got 65 people watching. I don't know if there's anybody watching on Facebook, if I am broadcasting to Facebook. But here we go. Yeah. Okay, so here we go. I'm going to get ready now to do a Julia set example. And so I'm going to save this as Julia set P. And I will make a JavaScript version of this. And if I don't, you guys should remind me. I'm going to clean up the whiteboard here because I'm going to need to use it. Okay. 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 Hello, everyone. Here we go. I'm going to have a little water. This is almost an hour in, and I'm basically recording the first standalone video tutorial, which will be about live coding the Julia set. So here we go. I've got my whiteboard marker. I've got my button to switch over there. I've got my lights on, and I think we're good. Okay. Orangelo, sorry, asks, when will you continue the Super Shape series? I might do that today if there's time. I also have this sort of fantasy of coming back just for like an hour after lunch later today, just to, whatever I don't get to but feel I really wanted to get to today, I'll do later. So that's certainly something I'd be happy to do. Okay, here we go. I am kind of, which one was correct? I said it two different ways. Okay, here we go. Oh, I need a tissue. I need a boost of energy, and there's only one way to get a boost of energy, and it's okay, ready for the Julia set. Okay, here we go. And here we go. Ready, everybody? Time for the Julia set. Hello, welcome to another coding challenge. In this coding challenge, I'm going to take the Mandelbrot set, which is here programmed in processing, and I'm going to convert that code to the Julia set. So I'm going to explain a little bit about what the Julia set fractal is, and then just write the code for it, play with it, make an animation out of it, do a few other things, and then I'll be finished. So first I want to say is I'm going to assume a little bit of knowledge, which you can pick up and watch the previous video about the Mandelbrot set if some of the stuff is confusing to you. Okay, I'm going to keep going here. So first, let me just though remind you what's going on. So the idea is that there is a canvas, and the canvas has an x-axis and a y-axis. But I'm thinking that canvas, though it exists on the screen with that x-axis and y-axis, I'm using it to visually represent something called the complex plane. What do I mean by the complex plane? Well, a complex number is a number written like a plus bi, where I is an imaginary number or the square root of -1. There's, think about that. It's imaginary, right? What's the square root of -1? You're going to be thinking for a very long time until you just decide, like, I can't come up with the answer, so I'll just make up an imaginary number that is the answer called I. So all complex numbers have a real component, that's the A, and an imaginary component, that's the B. And so the x-axis represents A, and the y-axis represents B. And so in the Mandelbrot set, what happens in the Mandelbrot, we're saying for every complex number C, which equals a plus bi, every complex number on this plane, we want to test the function where z of some iterative function. So z of zn plus 1 equals zn, the previous z squared, plus that complex number. So if we start the first, right, z sub 0 would be c, and then z sub 1 would be c squared plus c, and then z sub 2 would be c squared plus c squared plus c, right? This is the iterative process that's going to happen over and over again. I'm mentioning all this. Okay, so now, one thing that we need to know is how to take a complex number. And I'm doing this again because I think it's worth it. A plus bi and square it. So if we take a plus bi squared, take a plus bi multiplied by itself, we get a squared plus abi, right? A times a plus bi times a plus bi times a, which is abi, plus bi squared. So this turns out to be a squared plus plus 2abi plus b squared times I squared. Well, I is the square root of -1, so I squared is -1. So this is minus b squared. And now we have a squared plus a squared minus b squared plus 2abi. So this is now another complex number with a real component and an imaginary component. And you can see that math is happening in the code all the way down here. So this is what's happening. We're iterating over and over again and looking at the, so AA represents a squared, BB represents b squared. So the new complex number is a squared minus b squared plus that, plus c, plus c, a of c. You can see that a of c. And then the b component is 2ab plus y. So x and y are remembering the previous a and b. Okay, so that's what's happening with the Mandelbrot set. And the whole point of the Mandelbrot is testing, okay, is the point going towards infinity? Or is the iterative process resulting in infinity? Or is it resulting in a bounded number that doesn't tend toward infinity? And my test to see if it's going to infinity is just essentially look at its distance from 0. A squared plus b squared is greater than arbitrarily 16. And typically you just can check 4, 2 squared is 4, but you can kind of play around with this because what I'm doing is also mapping the number of iterations it takes to get to a certain color. And so there's a variety of ways you can kind of approach this in here. There's a strict mathematical approach, but I'm all over the place and trying different things. So you can see doing that and then just setting a pixel color based on how many iterations there were, and then we get this particular famous, well-known pattern known as the Mandelbrot set. So that's my recap of the Mandelbrot set. You don't have to watch that previous video after all. Let's talk about what the Julia set is. So the Julia set is actually something very specific. And I'm going to use this Paul Bork site, which has to do with this particular insane-looking function, z to the 4th power. The Julia set is named for a mathematician named Gaston Julia, who was looking at this particular crazy polynomial expression. But I'm going to look at kind of what is more conventionally known or thought of as the Julia set itself, which is actually connected deeply to the Mandelbrot set. So what you can see, Julia set are often thought of as like Mandelbrot dust, these patterns that emerge out of these like pieces of the Mandelbrot set in a way. And so there's a key difference in how the Julia set works. The way the Julia set works is instead of C itself being related to the very pixel that you're iterating, C in the Julia set is actually just a constant. So Z sub 0, the first Z is equal to the complex number represented by the pixel, but the thing that you add to it, the C, is actually just a constant. So while Z sub 0 changes as you move along, C always remains constant. And I'll show you in the code, I can actually just change 2 things in the code in 2 seconds, and we'll see the Julia set. So let me show you what I mean by that. And somebody please make a version of a rainbow Julia set for me. I'm going to do everything black and white. So let me show you what I mean. So one thing I'm going to do is I'm going to go to the Wikipedia page and I'm going to scroll down, and you can see there are different results that you can get. And let's pick this one. Like, I want to get this particular result. So look at this constant. This is a complex number with both a real component and an imaginary component, and it's a constant. So what I want to change in the code is, instead of that constant, right, each iterative process, I take the squared, a squared minus b squared, and 2ab, and add it to the particular complex number that I'm iterating. But instead of that specific x and y saved complex number, I want to just use these. So the constant. So this would be negative 0.7 something. So I'm going to change this to that, negative 0.7 something. And this, I'm going to change to negative 0.3. So now, if I run this, there we go. Look, I've got the Julia set fractal with exactly the same code. I didn't really change anything about it. So that's the secret here. The Julia set is really just a little bit of a trick in many ways. In terms, if all you care about is the visual pattern, it's just a trick to use a constant instead of the actual complex number that's associated with that pixel. Now, what I really should do to improve what I'm doing here is make that constant a variable. So what I'm going to do is I'm going to comment that out. I'm going to go backwards, and I'm going to, here inside draw at the very top, I'm going to add CA, referring to the A component of the complex constant, and I'm going to make a variable called CB. And I'm going to get that for CA, and I'm going to make that for CB. See, that's going to be CA, and that's going to be CB. Then what I'm going to do is I'm going to go down here and change this to CA and CB. So now you can see, there we go. There is my this particular Julia set. So now we have a mechanism by which I could kind of just keep going and be like, oh, interesting. Let's grab this particular number, which, you notice, by the way, this particular pattern only has a 0 for the real component. So I'm going to go and I'm going to just change this to 0 and this to 0.8. And I'm going to run that. And you can see there's that pattern. Matches exactly what we just saw on Wikipedia. I'm doing that'll be the thumbnail for this video. Okay, so this is interesting. We're getting somewhere. Now, let's say I want to animate this. There's two things that I want to do in this video. Number one is I just want to make this animate. And number two, I want to look at how I might use a mouse over the Mandelbrot set itself and see the Julia set associated with each point on the Mandelbrot set itself. So I'm going to do kind of two examples here. And then also I should really probably correct, I'm still using the same escape test just to see if the distance from 0 has gone beyond some arbitrary value, right? Really, to test if something goes towards infinity, I need to actually wait and see if it gets to infinity. But because I'm working in a computer program that's finite, and I just want to have some escape value. But typically, what you might see, let me just correct this now with the Julia set implementation, is actually look at not the distance from 0, but the distance from this particular Julia set value. So if I say CA2 is CA times CA, so this is CA, CB2 is CB times, so if I square CA and CB, then what I can do is actually check if that distance no. This is wrong. So I'm going to make this slower, but hold on. I'm going to have to write this here. What I want to do is say I'm going to make a variable here. I'm going to say the difference minus A minus CA, and the difference B is B minus CB, and then I want to check if difference A times difference A plus difference b times difference b is greater than that. Okay, so I'm making a slight correction here. Anyway, you can see it pretty much looks the same, but I believe I have a kind of higher degree of accuracy in terms of how the Julia set should actually behave. So I'm just checking that sort of, and by the way, I'm avoiding using the square root to increase performance. With the Euclidean distance, I need to take a square root, but I'm avoiding that. So I don't, I hope I haven't like lost some people in this sort of like distance thing, but you can kind of just copy this, and it's a little weird, or ask me a question about it. I'll make a video just about how this distance stuff works if this is confusing for people. So somebody in the chat, by the way, asked about, yeah. I think I'm still, time out, pause. This video is going to get edited. Let me ask you guys some questions in the chat. So this is, I don't want this to be in the tutorial because I've confused myself here. So Jules Jam asks, why do you need to take into account the original values? Does anybody in the chat have a good answer to that question as to why this is, I've just sort of seen this in implementations that the sort of accurate, the quote unquote proper way of doing the Julia set is to take the distance between the current value and the original constant. And then the other question I have is is this right? And did I have it wrong before? Because let me go back to my Mandelbrot set, Mandelbrot P. Yeah, why am I using AA here? That's wrong. That's the previous generation. It should be this, right? Yeah, I had that wrong. Ah. Yeah, that's what I thought too, Jules Jams. And then I saw, because when I read the Wikipedia page and other pages about the Julia set, all I saw was that it needed to diverge, get to infinity. So, and I guess that distance from, I don't know why I saw a lot of people testing its distance from the original values. So I kind of want to cut that out because that just made things confusing. I don't know where to pick up the previous video, and I kind of want to like leave that out. But also I just noticed that I had a mistake. It really should just be this. I don't know why I was taking this. But even so, it's not that different. These complex numbers I'm picking are rather small. So if the distance from that versus the distance from 0, it's a very small difference between those. So anyway, somebody can maybe help me with this. I'm going to come back, and I'm going to take this out. There's going to be an awkward edit for sure. And I'm just going to go back to this, and there we go. This is good enough for government work, so to speak. Oh, because I have the a squared here. But I want the next generation. Like I'm testing, I guess I could test, in other words, like, oh yeah, I could put this here, right? And then I could do this. This is really what I want to do. So this now to me is is a good way of doing it. Infinity. So I think, okay. Also just do greater than 4. I know I could just do greater than 4. Do that. Yeah, you're right. I'm just going to switch it to greater than 4. For some reason, before I was getting not as much of a range of color, but it looks like it's working fine. Okay. All right, everybody. I don't know where that video should get cut out. Yeah, it's, and we might be able to see if first of all, I'm just using floats. Like really, I should be using doubles and, do all sorts of accurate math to really zoom into this, but this is less important here. Okay, I'm going to go back into the video tutorial. This will get edited. And it's just going to have a very awkward cut at some point. And what I'm going to do, and what I have, this is what I had, I think, right? Yeah. Okay. Okay, so I'm gonna come back from an awkward cut now. Ooh, that's a great idea. Oh, thanks, Peter in the chat suggests I change the color mode to HSB, which is kind of a really cool idea. I'll do this in the, whoops. I need to, yeah, I'll do that later. Okay, that's a great idea. That'll be the rainbow. Oh, perfect. Okay, sorry everybody. I'm going to come back from that cut now. Back from an awkward cut, I kind of went off at a misdirection into something that wasn't so important. You can watch the archive live version of this for all of the chatter about that. But the only thing I'm going to do is actually, right now, is just move this up here. Because technically, I want to check if it's going toward infinity. And with the Julia set, I actually only need to check, it's good enough just to check if it's greater than 4. Once I square those values, I can check here to see if those values have gotten greater than 4, and then iterate to the next generation. And you can see here, I've still got the Julia set going. Okay, so there's a lot of things I could do here, and I want to do a couple things. The first thing I want to do is just make this animate. So one thing I could do is in these constant values, instead of having them, before I get to that, let me show you something. So this is a particular Julia set where only the imaginary number, which has no real component. The real number is 0, the imaginary number is 0.8. But if I actually try to pick one where there is no imaginary component, one thing you'll notice is that the Julia set is always perfectly symmetrical if there is no imaginary component. So we could keep trying different values. I don't know if I'll get something. And you can see here is another perfectly symmetrical Julia set. So if the imaginary component is always 0, you will get perfect symmetry. But one thing that I want to do is I want to just say, let me map the mouse value, which goes from between 0 and width to between -1 and 1, mouse x value. And let me also map the mouse y value, which goes between 0 and height, to between -1 and 1. And now what I can do is you can see as I move the mouse around, I am seeing all the different Julia sets. Now, ultimately, what I wanted to do is put the Mandelbrot set next to this. It's essentially the same thing. So as I move the mouse over the Mandelbrot, you can see the Julia set next to it. And maybe I'll leave that as an exercise to somebody. You can see just on Paul Bork's site here, this diagram is what I intended to do. As I move the mouse over the Mandelbrot set, you would then see the Julia set, the corresponding Julia set, the dust, so to speak, next to it. But this is kind of a nice effect here. And you can see something about this range of -1 to 1 is kind of a nice range to use. And I can try to get, if I get to 0, where's 0 along the y-axis would be here. So these should be all the symmetrical ones. But you can see I'm not exactly at 0. But you can see if I'm at 0, I've got the symmetrical one. So you can see I can, someone can make a nice dancing GIF. I should add some music here. I'll do that. I'm just going to do this in the middle of the video. I don't care anymore. Dancing Julia set? Okay. But what I want to show you, what I think could be interesting to try, is instead of having it be mouse interactive, a really quick way that I could have those values in the Julia set adjust automatically is I could use a sine wave. So what if I had an angle and set that equal to 0, and then, let me comment this out, and then I say float CA equals sine of that angle, and float CB, I'm just going to make the imaginary component 0 for right now. And I'm going to say, oops, and not A, angle. And then I'm going to have that angle increase over time by some amount. And you can see, look what's happening now. That it's oscillating between -1 and 1. So you almost have this breathing Julia set. Let me zoom in on that a little bit. This would be good for meditation. So the other thing I could do is I could oscillate only the imaginary component. I could set the real component to 0. And now you can see this sort of oscillation happening here. It almost has this left and right feel to it. Then what I could do is I could oscillate them both and have this one kind of be at a different period. I'll just multiply the angle by something. And you can see what's happening. We should have this kind of infinite set of oscillating Julia fractals. And I just want to sort of see, you can see it's animating quite quickly. I want to just sort of see how far I can push this. if I up the resolution a bit, if processing performance-wise is still good. I'm going to go to like 1000 by 800. So you can see performance-wise, it's starting to slow down a little bit, but I'm still able to get pretty fast performance out of pixel operations. So I will make a JavaScript version of this, but you'll see that Canvas pixel operations in JavaScript without doing some like WebGL magic are going to be much slower. Okay, so I think, so let's do one more thing. So let me put this back. One thing that I think would be useful is we need this Julia set to be a rainbow. So I'm going to leave the exercise of putting a Mandelbrot set and a Julia set next to each other for somebody on the internet to do and share with me, or maybe I'll just post the code to that. We'll go with this video, and this should now say Julia set. But what I want to do is change the color mode to HSB. So instead of reading the red, green, and blue values of a color, I'm going to make colors based on hue, saturation, and brightness. So what I'm going to do down here is when I make the color, since I have this sort of crazy formula based on the number of iterations, sorry, let me go over here and grab this. I'm just going to put this in a separate variable called H for hue. Then I'm going to make a color hue with a saturation and brightness of 255. That's, why does it not like H? Duplicate variable H. I used that for something else. HU for hue. Okay, so let me run this. Ah, there we go. There's my rainbow Julia set, finally. And I could potentially, I don't know, we could play with these values a little bit too, or the brightness to, actually, I don't know why I even considered playing with the saturation. And we can say, here's my lovely rainbow Julia set. Now, this is a good screenshot, but I need to pick a good, so let's go back to Wikipedia. I'm in this video. Let's look for this one. 0.8, this one looks kind of nice, right? 0.8.156. So 0.8, 0.156. Ooh, I didn't get that right. Something's negative probably. Oh, negative 0.8. Negative 0.8. There we go. Ooh, how lovely. So this will be my thumbnail for this video. I should do this. I should do that after the video, but you're watching me make the thumbnail in the video, whatever. Okay, and that's it, I think, for this video. Oh, here's the thing. One thing that I'm not doing is the zooming. So this would be an interesting exercise for you guys. The range is defined in this particular code by these values W and H. So for example, if I were to change this to 2, you're going to see I'm quite zoomed in on it. So that is also something I could use to animate. For example, what if I said the absolute value of sine of that angle, times 5, this would sort of zoom in and out. So you can see here I am zooming into us. I'm zooming directly into the center, which you can see like kind of zooms into blackness, but you could probably figure out like where's the sort of point you want to zoom. Also, at a certain point, these numbers are getting smaller and smaller and smaller and smaller and smaller, and the degree of accuracy I'm going to get with floating point math won't work so well. But I encourage you to sort of explore the zooming on your own and sort of see how that, and you can see how it's like really slowing down also as it gets, computation-wise, as it gets closer and closer in. But that's something you can also explore with and play. And I could even put this back. This will be my final move here, that we could sort of see it zooming as those values are changing as well. So this is the full finished version. Thanks for watching this Julia set tutorial. I hope that you learned something. I hope I didn't get too much wrong. I usually get quite a few things wrong, but I'll hear from the internet with corrections and make them again in a future video. Thanks very much, everybody. Goodbye. All right, chat room. How is that? I think I'm pretty pleased with that. It was, I think I'm going to comment out the zooming. Leave this example without the zooming. But leave this in there. So this will be the sort of finished version of the example in terms of the animation. Okay, wonderful. I'm excited to have a nice Julia set tutorial. I feel like maybe that'll be like, that's good Google SEO. Like people must search for that on YouTube. Program the Julia set or something. That's going to be a little awkward to edit there, but hopefully hopefully I'll be able to figure it out. I want to cut out that thing about the distance part. That was too confusing anyway. Okay, so it is close to noon. I think I want to move to sound stuff now. So I'm going to save all this. One thing I should mention to everybody just briefly is that Mathieu, who does the editing and uploading of the videos for me, thankfully with the sort of Patreon funding I have now, I'm able to fund a bunch of different things like buy some new equipment and pay for editing and channel organizing support. But he is traveling this week, so it will probably be a little bit slow to get some of this archive will be available soon that people can watch, but to get the actual standalone videos might take a little while. Okay, so once again, so first thing I want to do is download all these sound effects. Again, this is from Studio Nora, a wonderful set of sound effects. And I'm going to look at my sound. Oh, it's been a half an hour. I'm going to look at my. I'm going to put these on the desktop. MP3, I think, is what I'll use. Oops, the cameras went off. So I think what I want to do is it says, yeah, sorry, I'm looking at the chat. I think what I want to do, so I have a list. Where is my sound list? I should have had this bookmarked. Let me find this. Oh, it's in my Slack channel. Hold on. I'm checking to see if I'm disturbing anybody. Now I'm going to check my, do I have that pinned? Oops, I forgot to have that pinned. I'm looking for my list of, I made a list of sound tutorials. And hold on, let me find it. It's on my Twitter. Sorry, I should have definitely had this bookmarked. And I'm looking here somewhere pretty recently. I made that list. You can see basically what I'm posting all the time. Here it is. Okay, so this is my list, and I'm going to keep this open over here. So I so far have done the first two. And so the next thing I want to do is add short sound effects to an example. And and what I want to do, sorry, I'm thinking about this. So, okay, so I need your guys' help for a second. Do I still have my server running? I have the snake game. This is something I made in a previous tutorial, which is how to program. So I could write, maybe I could add sound effects to this. That's option number one. And another option would be running it, no, Space Invaders. This one, which I called Flower Invaders. Maybe this one would be better because there's more things that could happen. I don't know. Did anybody have a preference? I don't have any way of doing a quick poll in. Okay, thanks, Jules Jans, for clarifying my previously the. So what do you guys think? Flower Invaders or the snake game? Anybody have a preference? So I'm going to get set up here. So what I need is snake. Okay, 2 people wrote snake, so looks like that's probably what I'll be going with. Oh, everybody wants snake. Snake. Oh, look at this. Oh, there's 1 vote for flower. Anecdotally, the chat room is saying snake more than flower. Yeah, I don't mean to improve the gameplay. So, because I'm really going to focus on sound. So, snake. There's definitely more call for snake. Okay, so let me go to the snake game, and I'm going to copy it and do snake game sound. The other thing I'll say is, like, weirdly enough, when I look at my YouTube analytics, by far and away, my snake game video is the most watched video. I don't know why that is. I don't know if I did a good job in that video or if it's just the topic. I remember making like a ton of mistakes and getting confused and having all sorts of problems. But that is by far and away a more popular video. So let's look at the code for this. I want to add some comments. So this is the snake. This is the scale of the grid. This is the food location. And then frame rate, pick a food location. I just want to add comments to this so that as I'm pick a food location, mouse pressed. What does that do? Oh, that was like a hack for testing. So I think, oops, let me go back to the snake game. Right, I just wanted to be able to test it really quickly by clicking the mouse. So I think I can comment this out and put it away at the bottom. This is moving the snake. And then animation loop. If this snake eats the food, and check if the snake hits itself or a wall. Update snake, and draw snake. Okay, and then we can look at the snake object and say snake location, snake position, snake speed, snake length, tail locations. So this is checking, check to see if it is eating food. And then this is set its direction. And this is check to see if it hits itself, which I'll definitely want a sound for. And update location. This is where I got so confused. Expand snake, newest position, and then move snake. And keep on screen. And then draw snake. So now, so does anybody in the chat have anything you think I should add before I start adding sound? Like that seems missing here, that's important to do. Oops. Now let me just see a question. If I can be, if I get it right. Yeah, and let me change the speed a little bit. I think I even want to make it a little bit slower. And maybe it doesn't need to be so big. Like I should make a simpler version of it just for oh, I'm in the wrong one. No wonder nothing's changing. Oh my goodness. I was like, why is it not changing? Yeah, it doesn't need to be that slow. It's like still a little fast. That's a little bit slow. Whatever. Going back to the center when you die. Okay, good idea. Disable moving backwards into itself. scores already include score. Yeah, so you guys, those are good suggestions. I definitely want to have it go back to the center. I think I want to add that. So let's add that. So when you die, it should, where its position should be, I had to start, so I should probably have it start in the center, which is, so this, by the way, let's make these global variables. That's kind of useful. But width and height don't exist up here. So I got to say this. So I'm going to fix the columns and the rows. Let's do that. And then I can have it start in the center by saying columns divided by 2, rows divided by 2. That did not work. What did I miss? Oh, wrap around the screen instead of dying. Oh, I like that idea. Why did that not start in the center? What am I missing here? Oh, it's not. Oh, I forgot that it's actually, its position, it's actually moving according, the way I program this. There we go. So those don't actually need to be global variables, but that's fine. I might use them somewhere else. It's a little awkward. I like the wraparound idea, actually. So instead of the constrain, let's do that. So where is that? It's in the snake. Let me change that here. And I'm just going to quickly add that. Change the Y, because that I think will make it a little bit easier to play. Okay, let's take a look at that, see if I did that right. Yeah. Whoops. Oh, look what that's doing. It gets me off the grid. Shouldn't, right? Why did it went off the grid for a second there. I should never change it. Oh, just because where it's starting is off the grid. I bet you if I do this, this will fix that. Oh. I'll just have it start in the corner. Let's keep it starting in the corner. And then what I'll do is I'll have it start over in the corner. I don't want to deal with this problem right now. And then when you die, let's also put it back in the corner. Oh, why did it start at the bottom? Oh, because it was moving up. So when you die, I also want to have its speed. So I should probably make like an init function or something. But I'm not going to worry about this stuff too much because, okay. Okay, so there we go. Great. Okay, I'm gonna yeah. All right, so I'm gonna, okay, so that's good enough starting in the top left. People can make, this. The point of this is not to make a great snake game, but just to add some sound to it. And what I want to just see here, okay. A rainbow snake, yeah, it definitely needs that. Okay, so now we need to figure out what are the sounds that I need. So I need a sound for, so one thing is there could be background music. I need a sound for when it eats a piece of food. Whoa. What just happened there? Yeah, I don't know what just happened there. I need a sound for when it eats a piece of food. And I need a sound for when it dies. Anything else? Okay. Everybody wants the rainbow snake. I definitely want a rainbow snake. Oh, you mean to have its colors be like the rainbow as it gets longer? Oh yeah, I should just add that really quickly. Okay, you guys are. I cannot resist. I cannot resist this idea. So what I'm going to do, I can't believe I'm doing this, but I'm going to do this really quick. I'm going to, right here, say fill. So the hue is, I'm going to map I from between 0 and this dot tail dot length to between 0 and 255. And then I'm going to say fill the hue 255, 255. So this should give me it's funny how the I can't. Oh wait, do I have my hack in there? Sorry, hold on. I got to add my hack back in. I forgot that I have something weird in this example, which is that whoops. It's a nice rainbow snake. But the first two are the same color because I'm drawing the head separately. Where do I draw the snake? Right, this one is separate. So and then I need to fill. There we go. That should fix that. Yeah. Okay, now we have a rainbow snake, everybody. What do you guys think? You like the rainbow snake? A sound when it gets longer. Ah. Okay, and now let me make the food something. Food is blue, and maybe I will say no stroke. Rainbow snake. Okay. I thought I fixed that problem. Oh, it's just not a very, until it gets long, there's not a lot of mapping to be had. Oh, I know what I need. Yeah. This will fix it. Hold on. Where do I display it? Map. Let's get rid of this -1. There we go. Okay. Yeah, it's doing it backwards, but good enough. Okay. Okay, everybody. On wrap, I should go with thank you. Thank you, Oliver. Made a very important correction that I forgot that it's drawn from 0, 0. So we want to see it. I think that should be right, which is the corner. So yeah. Okay, here's the rainbow snake. I'm kind of addicted to playing this now. So why? Yeah. Anyway, Snake gets faster when you eat food. Interesting. Okay, so there's lots of ways this game could get better, but I need to add sound to it. That was the point of this. Okay, everybody? You got me distracted. So I am now going to look at the sound effects. So let's think about, so music I could add. So this could be background music for the snake. And then I need food for when you eat the food, sound for when you eat the food, which would probably be something like, that's nice. It's a little long. Oh, I like that one. Ooh. I don't know. I'm going to pick one of these alerts. Let's check out these. Ooh, that's a good one.
Hello.
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 All right, I got to do this one.
Hello. Hello.
Maybe that when you die?
Hello.
Is it really just, I only have two sounds when you eat the food and when you die?
Hello. Hello.
I guess it could be, you could get a different sound for each piece of food depending on how long you are. That's kind of interesting. 7 and 6. Somebody said sounded good. Okay. So what I'm going to do is I'm going to make a folder called Sounds. I'm going to kind of do this. Actually, you know what? I guess I should do this in the tutorial. So let me just get the Finder sort of set up here. And then let's look at this license. Yep, so I can do anything but sell or rent the package, which I won't be doing. And I'm going to use the MP3 versions of the sound. So now I have this. Okay. I have the game going here, and I don't need that anymore. And I have my code. There we go. Okay, a bonus fruit. You guys have so many good ideas. I really just want to focus on the sound effects thing. Actually, I realize why I wanted to do the flower invaders is because there is a particular issue that comes up when you have a repetitive sound effect. But I've gone so far with the is playing thing. But I'm gonna do 2 videos. I'm gonna do both. Okay. Better reset the cameras. I got to get started with this. Okay, and now I'm going to erase the Julia set stuff. I'm over here, by the way. Here. I really should, while I'm okay, I'm back over here. turn the sound off. Okay. And whoops, I minimized the browser. And okay. Speeding up the music as the snake gets faster. Oh, okay, these are great suggestions. Okay, let me make a list of them. I love these suggestions. Okay, so let's add, okay, so sound effect for eat food, sound effect for, is there another word besides die? Start over. I don't know why. And then background music. And then speed and of game and speed of music change. Speed of game and speed of music change the longer the snake. Okay, so that's my list. Let me check the chat. Make the background the Julia set render based on the current position of the snake. I like that. The one thing that I want is I want it to have a sound like in the Flower Invaders, like essentially like if you press the spacebar a whole bunch of times, the sound plays over and over again, but not have it do this thing. But I won't worry about that too much. Okay. Okay. Here we go. All right. I better get started. So let me see if I'm ready for this. I have the snake game here. I have the sound effects package here, and I have my code here. So I don't see what else I could possibly need. I think I'm ready to do this tutorial. This, by the way, let me just see. This is, if I look at the sound, this would be part 5. So by the way, if you're wondering, this is now, I have a playlist, which is p5.js sound, and I've done 4 videos so far, which is loading and playing sounds, play and pause button, timing jumps and cues, and then amplitude analysis. This will be part 5. And I think I'm just going to use preload. And I could later demonstrate if there were a lot of sounds like a loading bar before the game plays, which maybe I'll do at some point. Oh, and a hello when you start. Oh, sound whenever you change direction. Ooh, that's a good idea. Not so there could also potentially be change direction sound. And that's good for the repeating problem. Okay, I'm going to do all these. Nick Tucker, shout out to Nick Tucker. Wants me to say his name in the video. Okay, all right, here we go. I think I'm ready to go with this. Okay, here we go. Hello and welcome to part 5 of my p5.js sound tutorial series. Now, in this particular video, I'm going to look at adding sound effects to p5 sketch. We looked at playing like a song in a p5.js sketch and starting and stopping it and manipulating it. But what happens if you have something like a snake game? So this is an example I made in a previous video where you can play a snake game, meaning you move about the screen as this snake and you try to gather up food, and as you gather up food, your snake becomes longer. So what would it mean to add sound effects to this particular sketch? So I have a few ideas. I made a list over here. The first thing I want to do is just add 2 sound effects. So a sound effect for each time you eat the food and a sound effect for each time you have to start over when you run into yourself. I also want to add some background music, and I want to look at seeing what happens. Could we manipulate the background music, having it speed up or slow down based on like how far you're getting in the game? And then also, there's an issue that comes up with working with sound effects if you have a sound effect that you're triggering many times over and over again. So I want to look at that, and maybe we'll add a sound for changing direction. So I'm going to do all of that in this particular video. Now, where am I going to get my sounds from? So there's lots of places on the internet where you can find sounds. This is a particular sound effects package. I will link to this particular sound effects package. It has a Creative Commons license. It's available on GitHub. I've already downloaded it. It has wonderful sounds in it that were made for the Coding Rainbow channel specifically. So you can see here this nice page. I can just test out what some of these sounds sound like. For example, this is
Coding Rainbow.
with me. Okay, so I already have all these sounds downloaded, and so what I'm going to do is go to the Finder right here, and this is my p5.js sketch. I have a libraries folder, and I have 2 JavaScript files and an index.html file. What I want to do, I think, is make a folder in here. Whoops, I'm in the wrong place. I want to make a folder called Sounds, and then I'm actually just going to take all of the sounds from that sound effects package and copy them into here. I'm not going to use all of them. So now you can see with my project, I have my JavaScript files, my HTML files, and now also this folder of sounds. And you can see, like, if I'm going to start with one of these alerts, you can see how they're named, alert-04.mp3. So this is going to be really important because I'm going to need to reference the file name specifically when loading the sound. So let's just make sure first I can do that. So I'm using there's a variety of different sound formats you can use, which are supported by different browsers. And I'm not going to get into that in this video. I'm just going to use MP3 files, which will hopefully work in most scenarios. So let's say I want to try this. Let's try alert number 6. So the first thing I want to do is go to my code, and I want to create, let's make this the sound effect where you eat the food, eat sound. And I'm going to add the preload function. I think what I might like to do in a separate video is show you how, if you have a lot of sounds, show you how to create a loading animation. Right now, it's just going to take a minute, not a minute, but take a few seconds for the sketch to load. And I'm going to say eat sound equals load sound. And then now, this is the name of the sound file, but I also need the path, right? If that was just in the root directory, this would be enough. But I think I said sounds and then alerts. I think that's right. Let's go back and look. Sounds and then alert, and it's with a capital A and with no S. So this type of stuff is typically case sensitive, and you've got to get the spelling exactly right. So just to see if this works, I'm going to go back to the sketch. And I should be able to just say right here, eat sound.play. So that's working. So in the console, I have it as a global variable. I can just play that sound. So this is actually really easy stuff here. I've loaded the sound. All I need to do is now find the place in the code where I eat the food. So that actually happens right here in draw. There's a function, the snake function checks to see if it's eaten the food, and then it calls this pick location, which picks a new location for the food. And so I could just add here and say eat sound.play. So now, when I run this sketch, whoops, I have to click in it to, you can see, there we go. It's working. All right, so that's the basic idea here. So now we need another sound effect. Let's add a second sound effect. And let's pick one. For when you die. How about this one? So I'm going to, this is under voice. So I'm going to say start over sound. And I'm going to load that one as well. And this one is in, where was it? Sounds, voice, and then cartoon laugh. And now I should be able to say, okay, well, where in the code this function s.death, that's what checks to see if the snake dies. And here, this is where all the reset of the snake happens. You can see I'm logging to the console. So I can say here, what did I say? Start over sound.play. So now I should be able to eat food. And eventually, I'm going to make myself. So you can hear the trick I'm doing to. This is I'm not very good at playing this game. Okay, so you can see that works. So this is the basic idea. All you need to do is load sound and call play at the opportune time. Now, actually, right now what I'm going to do is I'm going to add another sound for change direction. So let's go back and pick which sound we want to do. Let's use, I want a shorter sound. These are all pretty.
Hello. Hello.
Let's say we wanted to use this hello sound for every time I change direction. So I want to just emphasize a point here. So I'm going to, in the sketch, I'm going to say hello, and I'm going to say, hello equals load sound. And I forget, this one is in voice, hello 01. And I'm going to say it there. And so sound/voice. Now I should say that, generally speaking, I would probably try to avoid spaces in your sound file names. It's all working just fine here, but sometimes file paths on different machines and different servers, spaces can confuse things. But it's going to work just fine. But if I were, I might rename some of these files just to like this to make it easier to work with. But for right now, it's working, so I'm not going to worry about it. So let's say what I'm going to do now is anytime I press a key, I'm going to say hello.play. So I could have a different sound for each direction. There's all sorts of, but I just want to show you something that comes up a lot with sound effects. So I'm going to run this. And so you can see with the way this is working, when I call play, it always restarts the sound immediately, but doesn't let it finish playing, which might be what you want. But if I wanted to make sure it doesn't play the sound until it finishes playing, if it always finishes playing the sound, I could say if hello is not playing. So there's a function in the p5.js library called isPlaying, which returns true or false based on whether the sound is playing. So if I say, if it isn't already playing, then play the sound. Whoops, I missed something here. Whoops. Now, what you can see is, it's actually kind of a long sound. So I can hit the keyboard as many times as I want, but it won't actually start the sound over again until it completely finishes. And there's a lot of silence there because the sound file itself has a nice long sort of fade out in it. Now, I wanted to mention something that I'm pretty sure is the case, and I'm going to look in the sound reference for a second. And I think what I want to look for is, there's something, time out. This tutorial is going to get paused. I've kind of gone off the path. This is going to get edited now. I'm looking for something that I have this memory of being part of the p5 sound library, which is like a setting for the play function. So we're going to look at sound file. And then maybe play mode. Yeah, there we go. This is what I was looking for. There actually is a play mode, restart and sustain. So it changes what happens when it's triggered in the middle of playback. In sustain mode, the playback will continue simultaneously to the new playback. In restart mode, play will stop playback and start over. Okay. So I'm going to just briefly reference this in the tutorial now, and see how that goes. Okay. Okay. Back from a brief edit here, what I was looking for is play mode. So this is a kind of secret little function. It's not so secret, it's there in the documentation, but it's something I often forget. There is a function called play mode in the p5.js sound library. And this actually changes the behavior of what happens when you call play multiple times on the same sound file in rapid succession. So we can see, I'm going to go back and I'm going to take out this is playing by default. And we're going to see what happens. Whoops, if I go back to my, oh, I lost my sketch here. So you can see what happens. This is the default behavior, which is always stops playing and restarts the sound. But what if I'm going to go back to this reference page, and what if I change the play mode to something called sustain? Whoops, this reference page. Sustain and restart are the two options. So I'm going to go to the code, and I'm going to say here, in setup, I'm going to say hello.playmode sustain. Now listen to the difference. I'm going to refresh this. It seems to be doing, it seems to not be doing what I expected. Let me change it to restart. I hear a difference. Time out. I gotta edit this again. I'm gonna come back to this. Hold on. I know, right? You hear the difference there? I guess sustain. Let me read the documentation. It's not doing what I thought it would do. Oh, it is doing it. It's just, it was working correctly. Is sustain the default? So what's the default? I might have been wrong. Yes, sustain is the default. It was working correctly. Okay, let me come back and do that again. So sustain was actually the default. I didn't realize that. Right? That's sustain, and I haven't changed the play mode. Let me just refresh again. Yep. And then if I change this to restart, yeah, it says so in the docs. Odd potion in the chat says it says so in the docs. You think I could have read the docs? Okay, I'm going to go back to play mode, p5.js. To get back to that page. And I'm going to mention this. And I'm going to mute this tab. Just this tab, I don't want it. Is this an example or the docs? Oh, this is not, this is an example. Yeah, this is what I want. Yeah, sustain mode. Yeah. Sustain is the default mode. Okay. Yeah, it's hard to hear that because of the small sound. So I didn't pick a great sound for this demonstration, but okay. Sorry, my nose is running all of a sudden. Okay, let me come back. Okay. Back, I was looking for, I found what I was looking for, which is the play mode function. So actually, I didn't realize it. Let's go back to the example, and I want you to listen very carefully. I'm going to press the key multiple times. It's a very short sound, so it's hard to hear, but it's actually always finishing playing hello and layering the sound over itself multiple times. This is actually what's known as the play mode sustain. So sustain is the default play mode, meaning if you trigger a sound multiple times, it's going to layer over itself many times. But if you didn't want that, you could actually change the play mode to restart, and you'll be able to hear the difference now. I'm going to refresh this page. So you can hear it doesn't, every time I press the key, it doesn't finish the previous sound. Which is perhaps not what I want here. It's a little bit awkward. And perhaps that's not the best sound. So I'm going to take that out. But I wanted to demonstrate that. This comes up a lot. In my Flower Invaders code example, there's a thing where you hit the spacebar and you launch water. So if you were hitting the spacebar a lot, you might want to think about how you layer that sound. OK, so I'm going to comment out this hello.play, and let's look at what we have right now. So we have the game here, and a sound is played every time you eat a piece of food. And then, by the way, I think I have a hack in here where I can just make it longer. So now also when you go into yourself, it laughs at you. So I can click the mouse. Actually, I want to make that the space bar. I just have a hack in here so that for testing, which just like increases. So I'm going to just say if key equals space bar. I think that'll be easier for me to do the testing. So, so I can just really quickly like make a long snake and hear that sound. OK. So now, what I want to do now is add some background music. So I have some nice, there is some music here. So music 01, MP3. So let's also load that. Var music. And I'm going to say music equals load. I'm going to just copy this. Music equals load sounds, music, and then music -01. And then what I want to do is say music.play as soon as the game starts. So now we've got our snake game, which I'm going to now play. I forgot that I was making a tutorial video because I'm just interested in this. Oh, I could watch it over here too. OK, so the point is now you see that I have background music playing. And I could put a button here to toggle the background music. But I want to try something which is just to see, could I make the game faster with each piece of food you eat and then also have the music speed up? So, so what I forgot that OK, so I'm going to mute this tab for a second. I should add a play pause button, but I'll do that later. OK, so now what I want to do is, now the speed of this game, I've done it in a kind of a tricky way, which is that I've just actually controlled. Typically, this is a bad idea. The speed of this game is tied precisely to the frame rate. Because, nothing could happen faster in the animation because the whole frame rate is. So I probably, if I needed to have other animations and things, would want to not mess with the frame rate, but this will work just fine and it'll demonstrate the idea. So one thing I want to do is make that a variable. So I'm going to make that a variable called frame rate. I'm going to start it pretty slow. I'm going to start it at 3. And I'm going to also put in draw the frame rate function. And actually, you know what? I don't need to put it in draw. I'll put it in, I'll do this more properly. I'll put it in setup. And then I'm going to adjust the frame rate every time the food is eaten. So I will call frame rate again in here, and I'll also say something like frame rate ++. So it's going to go, and just to be sure it's working, I'm going to change this by like 10 frames per second for each piece of food right now. So it's slow, and then you can see it's really fast. So I don't want it to change that extreme, so I'm just going to change it by 2. And then, now that I need to see that that's working, let's also say music.rate, or what was it? I forgot what the function is. Let's go look in the reference. So I want the p5 reference page for sound file. And you can see that the function is rate. Sets the playback rate of a sound file. We'll change the speed and the pitch. Values less than 0, reverse the audio buffer. So I'm assuming, for example, if I say rate of 2, it's going to play it twice as fast. So what I want to do is I want to say music rate map the frame rate, which has a range from 3. It started at 3 to like, maybe it's going to go up to 20, I don't know, to between 1 and 3 times as fast. So, and then I'm going to change the music rate to that music rate. So let's see how that works right now. So I'm going to go back to the game. And, oh, I need to unmute the tab. Oh, and by the way, when I start over, something I need to correct, when I start over, I'm going crazy. I can't mute it really easily. I wish I could. You know what I can do is I can at least refresh the page. So it's, when I start over, somewhere in here, I also need to say music.rate1 so that the music goes back to 1. And the other thing is that rate really picked up fast. So I'm going to make the mapping much less extreme. And probably I don't need to do this as a mapping. Maybe what I should just do is make a variable called music rate. This might make more sense. And have that equal to 1. And then forget about doing a mapping. Just set the music rate and then just increase it by like a little bit, like 1% faster for each time a piece of food is eaten. So let's play this again. Ready? Can you hear it getting faster? Okay, I'm terrible at this game. If anybody's actually just watching YouTube make me bobbing my head awkwardly and like playing this game, I'm really impressed. Okay, you get the idea. That 0.01 was like very little. So, I should probably make it at least like 0.05 for anything to happen. This is really what my life has become. Rainbow snake game with music speeding up. Okay, you guys get the idea, okay? So this is the end of this video. I showed you how to load a bunch of sound effects, how to put music in the game, how to dance with the music, how to make it speed up. I think I've got to everything on my list. I feel like I need to like fade this out. I don't know how to fade the audio. I need to like build that into the code. But I'm just going to mute the tab and say goodbye. And we'll be making more sound. The next set of sound tutorials I'm going to make are actually about sound synthesis. So I won't be loading any files at all. And then I also want to make one at some point. Remind me if I haven't done this, if it's not on the channel, maybe one that shows if you have a ton of sounds, how to have like a loading bar or something like that as your program starts up. Okay, thanks for watching, and I'll see you soon. I forgot to reset the frame rate. Yeah, I'll fix that. Okay, so that'll be the end of the video. I'll reset that in the code right now, just so when I publish this, here. So this would, by the way, I would really recommend making like a reset game function, so that like all this stuff to reset the game would be somewhere else. You could also call that in setup. Okay, hopefully that was useful to you guys. It's 12:45. I'm doing pretty well. I've done two things: the Julia set and the what did I do? The Julia set and this sound tutorial. What's the other sound stuff I need to do? I lost that Slack file I had. Oh no, I still have it open here. Sound synthesis. Oscillator. Okay, ooh, sound input. That I could do. I could do the sound input one really quickly. Maybe I'll do that one now. Sound synthesis, I feel like I want to do a little reading. I know how to do it in P5, and I could quickly make the example, but I feel like one of the things I don't actually really have at the sort of tip of my tongue and tip of my mind is kind of like a bit more about sound waves and how they work. The difference between square waves and triangle waves and sine waves. So I want to like look at that a little bit. Next time we need a score bar, yes. I did show how to color the Julia set. Yeah, I used HSB mode to do that. I'm trying to think of something I could do kind of quick. I feel like, I guess it's 12:45. Maybe what I'll do is I will take a lunch break now. And have this stream end. The problem is and maybe I'll try to come back this afternoon. The things that I'm thinking about that I didn't get to today, I'll show you guys. Here's the next things on my mental list. One is more sound stuff. Like I wanted to start doing the sound synthesis stuff with oscillators, and eventually show you how to like make a piano that you could just click on and play different notes, essentially like a synthesizer. So I want to do that. I'm not obviously going to get through all of that today, but I could at least do this first sound synthesizer. And then the two other code challenges that are kind of on my list here. One is a really simple thing, which is called disk point picking. It's not a really simple thing actually, but it's just to show the difference between when you pick points randomly in a circle, how you get an even distribution versus a distribution that clusters near the center. So that's one thing, as well as super shape. And then I want to do this. So I don't know if people have kind of, I'll probably in the Slack channel, I have a Slack channel associated with the Patreon. I might sort of hear from people if a lot of people there at least wanted the Julia set today, which now I've done. So I think what I'm going to do is actually take a break now because it's almost 1 and this has been 2 hours and 15 minutes. I think that's a good amount of time for a live stream. I would like to come back and do one more thing this afternoon. So you can tweet me at Schiffman if you want to like put in your vote. You can join the Patreon and talk in the Slack channel, or you can put it right now in the chat. The things I'm thinking about are super shapes, disk point picking, and sound synthesis with the p5.js oscillator object. But I think I'm happy to take about 5 to 10 minutes right now if anybody has any burning questions. It doesn't even have to be a burning question. So I'll open question time now. I realize you guys in the chat are like about 10 to 15 seconds behind me, so I'll wait. Feel free to ask any questions. I'm going to check. Oh, wow, okay. So, by the way, I was feeling very neurotic about doing this recording while there was a class going on in the next room. So I sent a message to the class Slack chat and asked if, and I'm told that nobody heard me talking the entire time. So I can be, I guess, as loud as I want. Okay, I don't see any questions in the chat. I'm going to give it another minute or two. And then I'm going to wrap this up. I'm going to check Twitch, which I have not looked at all. According to this, there's 5 people watching on Twitch. I don't know why my channel says undefined. And Facebook probably ended a while ago. Wonder if that worked. Yep, that definitely worked. People are giving me comments like, don't do the square roots, just the squares. So that we've seen. Okay, and okay. Odd Potion asks, and this is not at all off topic, which is a great thing to cover before I go. This is how often do you live stream? So I'm trying to live stream at least once per week. And I often have been doing it twice per week, or even like 2 times in one day, like one day per week, but morning and afternoon. And if you want to get email announcements, I suggest you go to codingrainbow.com, codingrainbow.com, and you can scroll down to this spot down here, get updates. You can put your email address in here, and you will get updates in terms of the live stream. If you want to interact more and have a chat and ask questions offline, you can subscribe to this channel's Patreon by clicking this button. And then I have a by invite Slack channel where we discuss topics and answer questions. And I also post in there updates about when I'm going to live stream. I believe that if you just subscribe on YouTube, it'll give you a notice when I'm streaming, but you won't get the advance notice. Okay. Prasenjit asks, and I apologize for mispronouncing your name, is there any way to change color of a line in p5.js? So a line is colored by the stroke function. So if you use the stroke function, it'll change the color. And by default, you pass stroke a RGB value. But as we've seen in some of my examples, you can change the color mode to HSB and do a variety of things. Okay, so Trip1666 asks, I just got here, but what were you doing exactly? So unfortunately, Trip, I'm at the end. I'm about to go in the next few minutes. I'm just answering questions for another 5 minutes or so. But today I did a Julia set in processing or Java. And so I did the Julia set, and I also did a tutorial about playing sound effects during a game. Do I have CodePen, or is there a great place we can all share our sketches with each other that you would recommend? Raymond asks. This is a great question. So I am kind of on the horizon is a p5.js web editor. And as that's a project that I'm helping to work on, and actually have a meeting on Thursday about it. So hopefully that's something that's going to be available by the fall. And with that p5.js web editor, the hope is that there eventually would also be some ways to create collections of sketches or share sketches easily. Currently, I don't have a great recommendation. CodePen is but CodePen is a really nice way of doing this. I keep meaning to make a how to use CodePen with p5.js tutorial. Maybe I'll do that this afternoon. I haven't been using CodePen that much. I'm keeping just things on GitHub. So all of the code for these videos gets posted to GitHub, and there's links usually in the description to find that code. One thing I'm really looking at doing is going back, and Mathieu is going to help me with this, creating a numbering system. I have like over 300 videos on YouTube. And this is, by the way, is Coding Rainbow number 44. So this is my 44th live stream. So I want to have a better numbering system so that people can find the code based on the number that goes with a particular video. So that's something I'm eventually hoping to do. So I need to get better at that sort of thing, and I'm always open and available to take suggestions. So if I could come back this afternoon to do another quick live stream, it would probably be around 2 or 3 o'clock. Eastern time, and I'll post on Twitter if that's happening. I won't send another email announcement about it because I don't want to blast that email announce. So yeah, if you're interested in contributing to p5.js and the p5.js web editor, please be in touch with me. Twitter @Schiffman is probably a good way. And I think the project is kind of in such an early stage right now that there's not really. It needs to get a little further along, but then I think having contributions and help would be super awesome. So I think we're getting very close to that sort of point. Great. I don't see any more questions in the chat. I see that there are 56 people watching currently, which is kind of amazing. I appreciate the kind feedback. I felt like on Friday it was a total mess, and today I feel like it was only 50% mess. I think the amount of the how well the stream goes really is like directly proportional to the amount of dancing that I do, I think. So, and Industrious Industries asks, says, I'm new to C++, can you give some basics? So I don't typically do C++ tutorials. There are some nice, my mind is at a blank right now. I usually have a go-to introduction to C++ guide. But I would say that if you're interested in getting better at C++ and the kind of creative coding community, I would check out Open Frameworks, also Cinder. But both of those creative coding frameworks have a lot of friendly tutorials and resources and community to help you get started with C++. Odd Potion asks, will you ever cover more advanced topics such as architecture, for example, how to structure more complex game systems? I think I aspire to covering topics like that. I'm mostly mostly my channel, I try to stay in the getting people started and going. And it's not that I don't want to cover more advanced topic, but I don't want to get lost in the weeds of like kind of obscure design patterns or optimization. I think those are important things, but in the kind of sketching, rapid prototyping, experimenting, playfulness type of spirit that I aspire to, I tend to stay away from those types of scenarios. But I do think that as I start to accumulate more content, there could be room for that. I also have to admit, like, I don't really live in that world so much. I make quick experiments, I look at something, I try to code it up, I make lots of mistakes, I kind of have things organized haphazardly. So, but if somebody has a particular suggestion of how, and I think I get into this a little bit in some of the nature of code materials where I'm dealing with more like a flocking system, which has a lot of different agents. And so there is some thread of that there, but if you have I think I would need a more specific suggestion of an exact kind of topic or scenario design pattern to cover that I could sort of research and practice a bit on my own or kind of live code on the fly. Thanks for watching today. It's now approaching 1 o'clock. Pathfinding, that's a good one for me to add to my list. I have some path following tutorials. I don't have, and I have a maze generation, which is a little bit like pathfinding. I'm also being asked if I will do some AI. I do have a genetic algorithms video. It's kind of not done in this style because it's just a recording of a presentation at somewhere else. And I do intend and hope to do some machine learning neural network tutorials at some point. But as you can see, like I don't get to a lot in one session. I think we do a lot and have a good time and answer questions. And but I do have that on my list of wanting to get to more machine learning related topics. Oliver always has the best suggestions of a quick, really simple coding challenge to do before I leave. So I know when Oliver is giving me my quick build a crypto system suggestion or anything else, it's time for me to go. And so I'm going to dance my way out of here. Thank you again to, I want to credit properly Arno Farr from Studio Nora. StudioNora.ca, who created these free sound effects, Creative Commons license, just for me using these tutorials. Thank you so much. This has been
Cutting Rainbow.
with.
The
See you later. Oh boy. I don't know why that.